Okay, so we're going to go on to question 2 in this video. And these are questions that relate to the fact families we discussed in class. Now, remember I told you that these are probably going to feel a little bit difficult because they're not in base 10. The reason that they're not in base 10, and we don't even tell you what base they're in, is we want you to think purely about the relationship between the numbers and not necessarily about the numbers themselves. If we were to give you a quantity in base 10, or if we were to tell you what base this is in, then your focus would be on purely converting that to numbers and crunching numbers as opposed to thinking about the concept that happens here. So we have a number system that it clearly tells us is not base 10, and we know the following relationship to be 2. 13 plus 4 equals 21. Immediately, let's write some other addition and subtraction facts that we know based off this. So let's write this down, and I'm going to label this first sentence here as my first fact. Okay. So what other things do we know? We should know that if I have the inverse of that fact, okay, that this same sentence should be true. And once we get over to the third and fourth sentences we can make, we're going to use the inverses or the subtraction relationship here. We know that if this plus this equals this, then what we put together minus one of the parts should equal the other part, okay? And that should be true no matter which part that it is that we choose to set up first, okay? So now, based upon the fact that we know that, let's see what kind of math we can do here, okay? This kind of foreshadows what's coming in future lessons in ways that we will use what we know about numbers to help us do some mental math calculations. And that kind of gets us thinking along those lines, okay? So let's use some reasoning here without actual math. Doesn't do any good for us to do, like, using algorithms because we don't know what base we're in. So let's kind of think about this. We have 12 plus 4, okay? What do we know about that in terms of the comparison to the other fact families up here? Do I have another sentence that's remotely close to that? Now, what I hope you picked out or what you see is fact statement number 1, okay? Fact statement number 1 is 13 plus 4 is 21, okay? Now, I know this is having 13 groups of 4. Okay, I'm sorry, no, it's having 13 with adding 4 more, okay? So the answer to that should be 1 less than what we get here. Now, why so? Here I started at whatever 13's worth, and I added 4 ones. We know that definitely has to be a 1. And then I ended up with 21. Okay, here I'm starting out with 1 less. So that means I should end up with 1 less. So comparing that to the first fact sentence should help us answer that. So let's go on to this one. What about 14 plus 3? Okay, when I compare 14 plus 3, somewhere along the lines here, I have a sentence that's pretty close to that. I would probably go with, oh shoot, I have drawn it, I've connected it to the wrong thing. Let's take that out. I have 14 plus 3. That should probably relate pretty well to this sentence because instead of 14 plus 3, it's 4 plus 13. Let's think about how they compare. In terms of 13 and 14, 14 is bigger than that by 1. Okay. In terms of 3 and 4, okay, here on this case, the 14 being bigger would have made this sum larger by 1. But the 3 being smaller would have taken this sum down by 1. Okay. If we were to maybe better so than comparing it to number 2, might have been a little bit clearer of a match to compare it to number 1. Okay, number 1 starts with 13 and adds 4. This example starts with 14 and adds 3. So here we start in this situation up 1 than we began up here. But what we add to it is 1 less than what was added up here. So basically, those should balance out. When we compare them to statement 1, we should still come out with the same answer. Okay. Now, let's keep trucking along with this, and let's compare this one to sentence 1 as well. So here we start with 1 more. That should increase us by 1. And we add the same amount. Nothing changes there. So we should be 1 more than what the final answer here was. We should be at 22 at that case. Okay, so let's look here. Here we have 21 minus 12. Okay, let's think about that. Which fact sentence does it most compare to? I would say to 3. You have 21 minus 13. What's the difference? I'm subtracting, I'm taking away 1 less item. And what should that do to the leftovers? Okay, that's essentially what a subtraction problem is. I start with something, I take something away, and I've got some left over. Here, I started with the same amount, but I took away fewer things. So how's that going to affect the leftovers? It should be 1 bigger. Okay, so instead of 4, we should have 5. Okay, 20 minus 3. In terms of what does that one compare to, I would probably compare it to statement number 4. Okay, how is it the same or how is it different? Okay, I have a subtraction. I start with some, I take away some, and I end up with something, some leftovers. Here, I started with 1 less than I did up there. So ultimately, that should affect the leftovers. I should be down 1. Okay, but here I only take away 3, and there I took away 4. So I started with 1 less, but I also removed 1 less. Okay, and that would kind of put me up by 1. And these, in a way, balance it out. Okay, I might have started with 1 less, but I also removed 1 fewer. So that should still end up with 13 as the answer. It doesn't change any. Okay, last number sentence here, we have 22 minus 3. I would also relate it to number 4 because they're very similar. Remember, in terms of subtraction, I start with some, I'm going to remove some, and then I've got some left over. Here, I started with 1 more. What overall effect it would be if this stayed the same and I started with 1 more, it would increase what's left over by 1 more. So this 22 being bigger adds 1. Okay, now here I took away 4. Here I only took away 3. So what if that was the only change? If I kept this the same and I took away less, that would make my leftovers bigger. So here I've increased my leftovers by 2. So this should be 15. Okay. Similar concepts will happen here with multiplication. So let's go and look at that. We have a number sentence, okay, and I'm going to write it as number 1. We have 14 times 2 equals 31. Now, we also know, or should know, that 2 times 14 should also equal 31. And then we're going to get our inverse facts. We're going to know that 31 divided by 14 must equal 2. And also that 31 divided by 2 should equal 14, based on what we've got there, no matter what base it's in. So again, let's start trying to match these up. Okay, 14 times 3. Let's see, what does that look most like? If it were me, I would say it looks most like this. Okay, what does this mean, 14 times 2? It means 2 groups of 14 equals 31, right? Here we've got 3 groups. So what does that mean? I've got to increase my groups of 14. Now, I know that we haven't defined the base here, but whatever the base is, I know that I have 1 more long and 4 more ones or smalls because I have another group of that. So if I were going to do that, I now would have 4 longs and 5 smalls. Okay. Now, I realize that when we do this, you might say, well, 31, I can't evenly split that into 2 groups and make this. Let's not think that far ahead. Let's just think of how it changes that. We don't have to get that deeply into it. Okay. So let's look at 15 times 2. Okay. Again, I would look up here and I would try to see which one of these statements it reminds me the most of. And I would probably go back to sentence 1 because it looks the same. We still got times 2. The only thing is now we have 15 instead of 14. Okay. So up here I have 2 groups of 14. Down here I have 2 groups of 15. So I have another group of 2. We can also think about this as 14 groups of 2, where this is 15 groups of 2. So what should be the ultimate change here? We should have another group of 2. So we had our answer of 31. When we add that other group of 2, I should be at 33 at that point. Okay, let's move down here. Keep tracking along with this, thinking about why and what's going on. So I have 13 groups of 3, 13 times 3. How would I change that? Okay, what's going on here in terms of what we're looking at? Now, again, I might go back to statement number 1 for that. Okay. I have it changed in another way here. Okay, I have my 13 groups of 3, and what I might also be able to do is I might also be able to think about possibly one of the other groups of sentences. But first, let's focus on what we've got. We know, okay, that when we write out these statements, okay, we have we want one fewer, okay, of the groups in this case. Hold on just a minute. This one may have been a typo. Let me look at it and see. We have one less group, but we are making, we have one less in our group, but we're making one more group. All right, so let's think about that. We have one less in our group, but we have one more group of that. So let's think about that. One less in each group. Let's just say we first had 13 times 2. Okay, how would that change what our overall solution here is? Well, we would have 2 less, right? Because we'd have 13 groups of 2 instead of 14. So that would change us by 2. Okay, now what instead if we focused on the 3 instead of focusing on the 13? Let's say we added another group. Okay, so what would occur if this stayed the same and then I added 3 groups of it? I would have 14 more. So I would add 14. So I'm down 2 on this aspect, but I'm up 14 on this aspect. So I should have a total change of 12. Okay, that one probably was not intended to be the way it is, but we'll roll with it from there. Okay, so let's look now at 35 divided by 2. Which one of these is going to most match that for us? Probably going to go here, right? Because it looks very similar. Okay. What's the difference between the way this looks? 35 is 4 higher. Okay. Now, what do you know about what's going on here? If it's 4 higher, there must be 2 more groups of 2, right? If there's 2 more groups of 2, this should be equal to 16. Last but not least, we have 45 divided by 14. I would say that most matches. I don't know what I've done here. Let me see if I can take that off. If I'm looking at 45 minus divided by 14, I would probably compare to number 3. Okay. Now, what's the difference between 31 and 45? Here, I'm up by 14. And that's one more group of 14. So here my answer should be 3. Okay, that's one more. I've added 14 to the start, but I'm making groups of 14. So that just relates to one more group. Okay. So again, like I said, this is new. It's probably very different in terms of thinking about it. It's not a big deal right now if you're exactly perfect about it. But what I want you to ask yourself is, do you understand how we're reasoning and rationalizing this? Because once we start using mental math expectations, you're not only going to have to use those strategies, but explain what the thinking is behind them. So we're kind of foreshadowing, okay? So let's look at the very last question before we can go here. To measure area, we count the number of squares that cover a flat shape. So let's draw a picture of a 3-foot by 4-foot rectangle and show why it takes 12 squares, each 1 foot by 1 foot, to cover the shape. Okay, so let's start there. I'm going to draw my rectangle. Might be nice if I had put graph paper on it here. And this is a 3 by 4. Okay, now what does that mean? I have dimensions of 3 and 4, and I'm going to specifically, for my purposes, make the height 3 and the length 4. Okay, so 1 foot, 1 foot, 1 foot here. So 1 foot, 1, 1, 1, that's 4. And then 3 here. Okay. 1, 1, 1. So it asks us what multiplication concept is this. If we have a 3 by 4 in this situation, how many of these tiles are we going to be looking at? Okay. So we should have 12 tiles. This is an array concept. Okay. Area is an array concept in mathematics. In fact, it is the foundation knowledge for area. Remember, we said we always want to link knowledge to something previously. If students have a concept of what an array is, then area will be a very easy concept for them to pick up. Okay. And if each square was a 1/2 foot by 1/2 foot, how many squares then would it take to cover the shape? So most people automatically want to say 24, and that's not exactly correct. So let's draw this. Let's think about how it might look different. Okay. We still want to create the same overall measurements, but the tiles are going to be different sizes. Okay, if I wanted to, I could draw the exact same square. I could just take out all of the markings in the center. So I know mine is a little bit bigger here. And in reality, we're thinking about the same size, right? It's still considered to be a 3 by 4 in terms of feet measurement. But you can't mark these off in whole feet anymore because the tiles aren't that big. So how would they change? The first thing I'm going to do is I'm going to go ahead and I'm going to mark mine off in 1 foot increments. 1 foot, 1 foot, 1 foot, 1 foot. Okay. Now, if I had 1 foot tiles, I would just lay a tile here and I would go on. But I have 1/2 foot tiles. Okay. So I have to be able to mark off length in 1/2 feet, not whole feet. Okay. So now we have 1/2 foot, 1/2 foot, 1/2 foot, 1/2 foot. Basically, we're going to have 8 halves instead of 4 wholes. That still equals 4, right? These two, these two, these two, and these two still produce 4. We still have a 3 by 4. Okay, so we've taken care of the length. Now let's think about the rows. Okay, last time we marked them off in 1 feet increments. Okay, we had 1 foot, 1 foot, 1 foot. It was a 3. Now we want to mark them off in halves. Okay, so we would have a half, a half, a half, a half, a half, and a half. Okay, so how many tiles do we end up with here? Since they're 1/2 foot each, instead of having 3 of them, okay, we have 6 of them. So this is 6 tiles. Down here, instead of having 4 of them, we had 8 of them. So we have 6 tiles by 8 tiles. So instead of going from 12 tiles, we had 3 by 4 in 1-foot tiles. We had 12 tiles. When we cut those in half, now we have 6 tiles by 8 tiles. So we have 48 individual tiles in this condition. So why did that happen? Why did it not just double to 24? Why did it go to 48? It's because we're dealing with area. We're changing these increments not only in one dimension, we're changing them in 2 dimensions. Okay, so we changed this 12 not by 2, but by 2 in 2 dimensions, which is a factor of 4. Okay, so that's how we end up with 12 times 4. It's going to be 48. Because we're dealing with area, we're not just influencing one linear direction. We're dealing with a change in height and in width. Okay. So if you have had some issues with several of these problems, first of all, I firmly expect it for question number 2. Question number 3, you may have just had to draw out, but I think you're perfectly capable of doing that. In terms of our class, if you're good with all of question 1 and the end question makes sense to you, so far you're in a good position. Okay, we'll talk more about question 2 as we move on in class.